So here we are back with the game engine project. All right, we've got the little project outline right here. I was thinking I kind of want to have this a lot more organized before we start actually coding. You know what I'm saying? Like with I don't know, flowcharts. I don't even know. Honestly, I have no idea. I've never once done a full project, much less organized project. All I know is that the checkers one is getting a little bit you know, you were there if you saw it. So here we go. Let's go back to ChatGPT and fix this up. Okay. So what do we want to tell it? Let's ask it a question. What's the best practice? What's the best practice for doing a project? Question mark. I'm also going to have a semicolon. Is it like planning it all out before starting to code so everything fits together well, or what? Question mark. Enter. Let's see what it says. The best practice for a project depends on its scope, complexity, and our goals, but in general, planning and iterative development work best. Okay. Here's a structured approach. Give me a second. Yeah. I got my cold espresso right next to me, ready to go. Start with high-level planning. Hold on. Oof. Yeah, I was playing it up. I was playing it up for the video a little bit. I'm guilty. All right, start with high-level planning. Before our code, we're going to spend some time understanding and defining the project. Okay. Define objectives. What's the goal of the project? Ergo, a working game engine for a top-down game? Yeah. That's what I like. That's what I like to see, ChatGPT. Identify features. List essential features. MVP. I forgot what that means, but I remember it was something important. Give me a second. Okay. Optional features and nice to have elements. Okay. We'll dive into all that. Architecture design. Outline how the major companies, the major components. Where's my glasses at? I don't have any. Rendering physics input will fit together. Use diagrams if helpful. Okay. Okay, we'll figure all this out. All right, technology stack. Decide on tools, libraries, and languages. C++, OpenGL, or whatever we choose. Benefits. Reduces waste effort from poorly integrated or redundant code. True. Helps ensure scalability and modularity. I also say true to that. So let's break down the work. We're going to organize the project into smaller, manageable tasks. True. We'll create a list of features or systems. Rendering engine, ECS. I forgot what that means. If we even went over that. Physics. We're going to have to define this. I don't know what that is. Break those into subtasks. For ECS. Define entities. Implement components and build a system manager. Oof, this is getting a little deep. All right, prioritize tasks based on dependencies. Input systems need to come before gameplay logic. Okay. I mean, I guess that makes sense. Dependencies. I guess. Okay, I guess. I mean, I think this is probably important stuff, but it's a little bit high for me or deep. It's either high or low for me. Whichever way we're going, that it's further. All right. But we'll figure it out. All right. Think of it like this. And I was just thinking about this while I was reading this out loud. It's like we're at the ocean. We're standing there at the ocean. And we don't even have a, well, we don't even have a boat, you know? And they're talking about, hey, go deeper out there. That's where this concept is. And I'm just like, I don't know. I don't know if I can swim that well yet. Maybe I'll just stay in this shallow end. You know what I'm saying? I don't know if my boat's able to weather the storm if the storm approaches. Anyway, regardless, we're going to keep going because that's where the fish are. All right. Iterative development. Instead of planning every detail up front, we're going to combine planning with incremental coding. Okay. Prototype first. Build quick prototypes to test ideas, ergo rendering a simple 3D project. Yes, we're going to do that. This gives early feedback on feasibility. Okay, I like that. Develop in small chunks. I mean, it's going to be feasible. There's plenty of games that do this. All right. Develop in small chunks. Implement one feature or system at a time. True. Test it thoroughly. Yes. And refine it before moving on. I like the sound of that. All right. Refactor is needed. Accept that our initial designs will evolve. Of course. Make improvements as the project grows. Of course. Of course. Benefits allows flexibility to adapt as we learn more about the problem or discover new requirements. Okay. What did that say? Allows flexibility to adapt. Yeah, to adapt as we learn more about the problem, of course. Okay. Or discover new requirements. So help avoid analysis paralysis. Oh, okay. Let's avoid that. I don't like the sound of it. Where over planning delays actual progress. Yeah. No. We're going to just get to a nice, draft, a nice draft of it, and then get to moving. We got things we got to do. Use version control. Yes. Set up Git repository. I still haven't made the Git video, but we're going to have, if you could just go on ChatGPT and ask it how to do Git so that, because making these videos, come on. Look. Okay. If you need me to make the Git video, let me know in the comments. How about that? Other than that, just ask ChatGPT for real. Come on. Because I've been trying to make it, and for whatever reason, I'm just not being able to do it. And it's really, what's the word? It's draining my morale about making a Git video. All right. Benefits. Wait, hold on. Use version control. Commit small, meaningful changes. Often with clear messages. Add basic camera control. Of course, that sounds fantastic. We'll do that later. All right. Benefits. Makes it easy to undo mistakes or experiment with new ideas. Yes, that's perfect. Facilitates collaboration if working with a team. You know what? We have to make our own game. Even if it's just a simple game with just two characters duking it out in the middle of the arena, we have to make that all ourselves. Okay. That's the way I feel about it. Now, if the duking out, in the middle of the arena looks cool and people are like, oh yeah, look that, maybe, we'll think about expanding into a crew or whatever, or a company or whatever. But until then, let's take care of this ourselves. You know what I'm saying? Of course. So test early and often. Oh, yes. Write tests for individual systems as we build them. Unit tests. Test integrations between components frequently. What? Hold on. Test integrations between components frequently. Ergo, does the physics system work with the ECS? What's the ECS? What are we talking about? As far as software planning, what's ECS? Entity component was designed. Okay, we'll get into that later. Write tests for individual systems as we build them. Unit tests. And then whatever. All right, benefits. Catches bugs early. Yes, I would like that. Saving time and effort, of course. Ensures new code doesn't break existing features. Yes, I would like to make it so that we can catch the bugs as early as possible. Let's take our time with this and get it bug free, because you know how crappy bug debugging is. Anyway, document along the way. Write brief notes about design decisions and how systems work. We'll have to get into some practice on that. Comment code to explain the intent behind complex sections. Yeah, so we can do that. Benefits. Saves time when revisiting old code or handling the project or handing the project to others. Helps maintain clarity as the project grows, of course. Iterate and improve. Periodically review our progress against the original plan. Okay. Be open to adjusting priorities based on challenges or new ideas, of course. Key insight. Combine planning and flexibility. While upfront planning ensures a solid foundation, over-planning can delay progress or miss unforeseen challenges, of course. You gotta hit the whatever the word is, sweet spot. Yeah, that's not the word I was looking for, but whatever. Iterative development lets us plan just enough to start coding while remaining flexible to refine our design as we go. This approach is widely used in software development, ergo agile methodology, okay, and is effective for both small and large projects, I say. Let's come back over here. Does ECS mean this? Does ECS mean the following? If so, write a concise definition of it. Boom. Yes. It's not as concise as I wanted. Very well. That's good enough. All right. Yes, ECS stands for Entity Component System. Here's a concise definition. Entity Component System is a software architecture pattern used in game development that separates data and behavior to improve flexibility and scalability. Okay. Entity, a unique ID representing an object in the game. Component, a container for specific data, ergo position, velocity, ergo position or velocity associated with an entity. Okay. System. Come on now. Am I an idiot? I guess so. Logic that processes entities with specific components, ergo a physics system updates all entities with position and velocity components. Okay. This design promotes modularity by decoupling data and logic, making it easier to add or modify game features. Okay. Okay. So let's ask it another brain buster, or just something we don't know. Let's say, okay, so as far as all that, what's the next step we should take for this game engine? Question mark. Boom. The next step depends on our current level of preparation, but assuming we're just starting out with the 3D game engine project, here's the recommended immediate action plan. Okay. Current level of preparation. Okay. All right. Set up our development environment. Before coding, ensure we have the right tools and structures in place. Do we really need to do that right now? I thought we needed to make... So we're already coding? So we're already coding? The planning is done? What? Is it complete? I don't feel like it's complete or even started, honestly. All right, so we're absolutely right to pause and clarify. While the foundational planning is mostly... Is it? All right, I think that ChatGPT's done its little hallucination again, because we didn't do nothing. Hold on. Also, start talking to me concisely until otherwise. Start talking to me concisely until otherwise interpreted. Not to? Anyway, until otherwise. No, to be commanded. Commanded? Sure. That being said, never mind. So that plan, that outline was good enough. Outline earlier was good enough. I don't feel like it was. All right. The earlier outline was a decent high-level roadmap, but for better clarity and execution, we should refine it into specific steps for an MVP phase. Here's a more actionable, concise outline for starting our engine. All right. Refined plan. Environment setup. Do we need a... This gets us something visible and interactive ASAP. Is that usually the goal? Is that usually the goal with this? To get something on the screen ASAP? Okay, so yes, the goal in the early stages of game engine development, is usually to get something on the screen as quickly as possible. For a few key reasons. Why focus on getting something on the screen? Validate the setup. It ensures our libraries, tools, and development environment are working correctly. That makes sense. Verifies our rendering pipeline and basic system architecture. Check those words out. That sounds like some real corporate talk right there, boy. We're in business now. Let's go. Not yet. We got to be making money first. But yeah, you know what I'm saying. Let's go. Feedback loop. Seeing progress early keeps motivation high. I get it. That makes sense. Immediate results help us debug and adjust plans as needed. Okay. Foundations for expansion. Once a simple render loop is in place, we can build systems like ECS, physics. I forgot what ECS was. Entity component system. Okay, yeah. Physics and input on top of it. Okay. Early visuals help us understand how different components interact. Here we go. Rendering plus input. Okay. Avoid overplanning. It's easy to get stuck in theoretical design. I guess that's what I was about to try to do. Prototyping ensures our plans are practical and can evolve. When not to focus on early visuals, if the project has unusual requirements, ergo network-heavy applications or back-end focused systems, we might prioritize, other subsystems first, but for a game engine, visuals are at the core. So early rendering is the logical starting point, of course. So let's do it. That sounds great. Sounds great. How do we do that? Sounds great. How do we do it? How do we do it? Here's a step-by-step guide to get something on the screen in our game engine. First, set up the development environment. Install tools. Install C++ compiler. We got it. Install CMake for project building. Install Git for version control. Okay, we can do all this. CMake. Okay. Install libraries. These ones. OpenGL for... Okay. Back up. Okay, let's go back up. Okay, so we want OpenGL or Vulkan over DirectX. What's up with that? What's up with that? Isn't DirectX the best? And that's why everyone uses it? Question mark, blink. Great question. Choice between OpenGL, Vulkan, and DirectX depends on our goals, platform needs, and project priorities. Here's a breakdown to clarify. For OpenGL, pros, cross-platform, works on Windows, Mac OS, Linux, and many other platforms, okay? Easier to learn, simpler API compared to Vulkan or DirectX 12. Tons of resources, decades of tutorials, and community support. Great for prototyping, ideal if we're just starting out with rendering, okay? Cons, outdated design is immediate. Its immediate mode legacy can be less efficient than modern APIs. Fewer optimizations, pardon me. Can't fully utilize modern GPU capabilities compared to Vulkan or DirectX 12. We're going to do this one then. Like, I mean, I'm cool, but okay. Maybe we should do this one because it's easier. And then, okay. Best use case, beginners or when building cross-platform applications where ease of development matters. Oh man, we got all these. Get ready, strap in. 21 minutes. Let's make it 23 minutes. All right, here we go. Vulkan Pros low-level control offers explicit control over GPU resources. That sounds important. High performance takes full advantage of modern GPUs and multi-threading. Okay. Cross-platform supported on Windows, Linux, Android, and Mac OS. Every time I see this, I think they're talking about PlayStation and Xbox. You know what I mean? Future-proof, designed for modern rendering needs. Okay. Cons, steeper learning curve, complex API with lots of boilerplate code. Okay. Slower development, takes more effort to write even simple rendering code. Okay. Best use case. When we want high performance, modern graphics, and fine-grained control, especially for larger or long-term projects. Maybe so, we'll see. DirectX 11 or 12, Pros, Windows focused, deeply integrated with Windows and Xbox systems, offering excellent performance. Advanced features, DirectX 12 is a modern low-level API like Vulkan, optimized for Windows platforms. It's the industry standard, used in many AAA games. Cons, platform lock-in. Only works on Windows and Xbox, DirectX 12 specifically. We gotta think about that. Less beginner-friendly, similar to Vulkan, DirectX 12 requires detailed knowledge of the rendering pipeline. Okay, we'll consider that. A best use case when targeting Windows or Xbox exclusively and aiming for the best possible integration. Nope, we can't do that. It's 2024. We have to target consoles as we target what are those other ones? PCs and Macs. I don't care about Macs. I don't care. We're not making freaking Photoshop here. You know what I mean. You know what I mean. Look, if I ever owned a Mac, like if I said, you know what, I need to buy a Mac because I am making full length AAA Hollywood films. Hell yeah, I'd buy a Mac in a heartbeat. In a heartbeat. But I'm not. I'm doing this. I got me this computer and I make videos and sometimes I'll play games on cinematic mode too. But, whatever. All right. Anyway, let's go back. All right. Maybe that was a bad thing to say. Give me a second. Oh. I just got hit with a little bit of weird feeling pain in my front brain on the left side of me eye. Right after saying that questionable thing, and I said, that might have been a little too questionable. All right. That being said, why not just use DirectX if it's the best? Platform lock-in. We already know. We saw it. We can't lock into that. DirectX is too old. We can't do that. What we should choose. Start with OpenGL. Easier. Okay, we'll do that. Transition to Vulkan later. Yes, and we're not going to do it. We're not going to do DirectX Vulkan, and OpenGL is the way. All right. So, yeah, that's what's up on that. All right. Okay. Okay, now where were we in the plan again? Question mark. Boink. All right. Oh, yeah, getting something on the screen. Current basic setup. Rendering, blah, blah, blah. Install libraries. Okay, how do we install those? How do we install those? How do we install the libraries? Let's see, shall we? Installing the required libraries depends on our operating system and package manager. Here's a guide for this stuff. Do we need all those? Do we need all those? Also, I told it concise, didn't I? This thing is like straight up running. This thing is like straight up running. What is this crap? What? Okay, what? All right. Okay, so we'll start with this. It looks pretty reasonable. All right, so we're at 27 minutes. We can keep going. I don't really want to though. I'm about read out. That was a lot of reading. Installing the required libraries depends on our operating system and package manager. Here's a guide to this stuff, which are all essential libraries for this phase. Okay. GL, FW, Windows, and Input. Download the library. Go to this place. We'll just do this. It's not that easy. Boink. A boink, I guess. Download the precompiled binaries for our system. Precompiled binaries for our system. Here we go. Bop. All right, we did that. Extract the files and copy the include folder to our project. Copy the include folder to our project. Place the lib VC 2022 or similar files into a libs folder in our project. Okay. Let's get on it. All right. Add to our project. Extract the files and copy the include files to our project. We're a project. Yeah. Let's go up a few from here. Checkers game, Laura build, view checkers. We didn't even make one. We didn't even make a project. C++ project. Let's call it game engine project. New folder. Game, top down game engine. Boom. All right. Download the things, extract the files, and copy the include to our project. Okay, let's go extract the files. Extract files. Is that what we want? I don't know. Okay. That's cool, I guess. All right. Now that we got that, something includes. Include. There we go. What did it say? Extract the files and copy the include folder to our project. Let's copy. Let's go to the project. Game engine. Oh, what? What? Hold up. What? Why wasn't that in there in the first place? What? Hold on. What? C++ projects, checkers. All right. Let's try that again. Here's this. Let's do this. Boom. Okay. We'll check the file structure later. We'll ask it about the file structure later. All right. Place the lib VC 2022 or similar files into a libs folder in our project. Okay. Let's do that. Get out of here, checkers. All right. New folder. Libs. All right, let's find the VC similar. VC 2022. Okay. Let's go to downloads. Let's make a new thing. Downloads. Right here. Right here. Libs 2022. This one. And toss it in there. Boom. Looking cool. All right. Also, I kind of want to check this out. Copy. Can we just copy it? Can I just go Control C? I want to check this out. Well, can you see this? Can you see this file structure? Oh, okay. Let's save that. Open. No. Open. Can it? Is it? I don't know. Let's try. I want to try it again. Open. No. Select. No. One more try. If it doesn't work, we'll try again another way. Can't do it. All right, let's just see if we can see this. Open. That's not it. That ain't it. Okay. Is there a way to just upload a folder to you and you look at the file structure? Yes, we can compress the zip file. Simply compress it. Simply, it says simply compress it. Ay. Whatever. Look, I gotta do it. I gotta do this. And it's not this either. It's the other one. This one. This one. Compress. How do you do that? 7-zip. Compress. Compress and email. Why does it keep telling me to compress it and email it? What is all this? Compress. Okay. No. All right. Simply. It said simply, didn't it? Didn't it say simply to do it? We'll just simply compress it. Add to game engine.zip. How about that? Okay, there we go. Close. Now let's toss this in there. Okay, let's try that. Boink. All right, here you go. All right, here. Upload from computer. Come on now. Where are we at? IS. Open. And send. What do you got? What do you got, GPT? Okay. Okay, cool. Great. All right, so here we go. Download the library. Download the what? Extract the files and copy the include folder to our project. Place this in the file. Link with CMate. Add this to our CMate lists.txt. What are you talking about? CMake lists. What's that mean? What's that mean? Is it inside of include? Nope. What's this? What is this? Where are we? Why are you doing this to me, ChatGPT? Because it doesn't know any better, of course. What are you talking about, CMake lists? What are you talking? What are you talking about, CMake lists.txt? Where's that at? Where's that at? I don't care if we can put the S on. Is a configuration file used by CMake. Okay. What does that have to do with anything? Did we do something to where we have CMake going on right now? Pardon me. The hell is CMake? So do I need this CMake thing before making this? So do I need this CMake thing before doing this? Question mark. Man, this stuff gets pretty. I mean, like, look. Okay, it is what it is. Like, it's not like we're going to free code camp and finding it all there for us ready to go. We have to. We're going to the river and we're trying to get the gold out of the dirt or out of the sultanate or whatever. I don't even know how panning for gold works, but we're trying to do whatever they do for panning for gold for this, if that even makes sense. I'm trying to pan for some gold out of that sentence. Anyway, that being said, I'm tired of this for right now. So we'll come back to this later. I know we didn't do it. We didn't actually do anything except for just read and type and say whatever to these guys and to ChatGPT. But I think we're at least at a point because I think we can make this CMake stuff work. We're just gonna have to start fresh on the next one because I'm beat and I still haven't made any headway on the checkers project. So I'm gonna put this one down for right now, and we'll see you next time.